All right, let's get the mic put here. All right, guys, welcome to chapter 12 of the Digital Investigator Handbook. All right, so today we're going to be talking about cloud forensics. Now, our core objective for this module is to have a clear understanding of the standard cloud service models and navigating things like the shared responsibility model, examining different things like AWS and Azure environments, and how do we do remote acquisition when it's in the cloud. Now, for the exam, we need to understand that cloud forensics shifts the investigator's focus away from physical disk acquisition towards log analysis and API-driven remote acquisitions. Now, the traditional physical chain of custody is fundamentally altered when you don't own the underlying hardware. So our learning objectives is going to be split into three main areas. First, we need to establish a baseline of cloud models. We'll break it down from IaaS, PaaS, SaaS, as well as public, private, and hybrid environments. Next, we'll cover responsibility, specifically how to navigate the shared responsibility model. And this is going to help us determine who owns the evidence. Okay. Finally, we're going to cover acquisition techniques for getting evidence out of things like AWS, Azure, or even SaaS platforms like Office 365. Now, the exam is going to test your ability to correctly identify which service model applies to a given scenario. So we need to have these models memorized and understand the forensics limitations associated with each type of model. So before we actually start with the cloud, we must define it. And we're going to use the official NIST definition, which describes cloud computing as a model enabling ubiquitous, convenient, and on-demand network access to a shared pool of configurable computing resources. That's a load. All right. A true cloud environment has specific traits, and that's really what we're looking for here. A cloud environment is going to have on-demand self-service, so no human interaction needed, right? We're going to be able to just click a button and get a server. We're going to have broad network access, being able to access it either globally or just through the internet. We're going to have access to resource pooling, otherwise known as multi-tenant infrastructure. And then we're going to be able to rapidly expand or contract, okay? And we're going to call that elasticity. And that means we can either scale up to more servers or scale down for less servers, whatever is needed for our environment. Now we need to memorize the 5 characteristics of cloud computing, and this is given to you by NIST 800-145. The exam is probably going to have you describe or identify characteristics like rapid elasticity or resource pooling from a multiple choice list. So you need to understand what they are and why we use them for cloud environments. Now NIST defines 3 primary service model, and we normally call this the stack. So the first model is going to be the SaaS model. This is software as a service. Think of it like Gmail, Salesforce. Basically, we just use it. The provider manages everything from the application all the way through the hardware. The next model is the PaaS, otherwise known as platform as a service. Think of this like the Google App Engine. You deploy your code, but the provider manages the underlying operating system and hardware. And then lastly, we've got infrastructure as a service. And this is something like AWS EC2. You manage the operating system, the applications, and everything up from there, but this provider is strictly going to manage the physical hardware and the virtualization layer itself. So for the exam, we need to know our forensic visibility and where it stops for each model. For example, in IaaS, infrastructure as a service, you can take a snapshot of an OS disk, But in SaaS, software as a service, you are almost entirely reliant on application logs, like login events and email forwarding rules, because we don't have access to the underlying operating system. Now, alongside these models, we're also going to have what we like to call deployment models. And so there are 3 different deployment models that you need to know for this exam. The first one is going to be the public cloud model. This infrastructure is open to the general public, like AWS, Azure, GCP, and this is a massive multi-tenant environment. So there's a lot of people here. The next model is the private cloud model, and this is infrastructure operated solely for a single tenant, for a single person, a single organization. It can be hosted on-premise by a third party, but the hardware itself is going on-premise or by a third party, but remember that the hardware is strictly dedicated. It's not shared by more than one tenant. Lastly, we have the hybrid cloud. Now, this is how most companies are now operating nowadays, and this is going to be a composition of 2 or more infrastructures. They may have some public, they may have some private, and when they're bound together, they're going to be a standardized technology. Now, this is going to allow data and applications to move between them. And think of like the campus here. When we log into our web portal at ClassLink, some of those applications may be hosted here. Some of those applications may be hosted up in the cloud environment, and some may be SaaS products, some might be PaaS products. It all depends on what is needed. So most companies now operate in what we call the hybrid cloud model. It's a shared model of just a little bit of everything. Okay. So let's talk about the shared responsibility model itself. Now, this is a very critical concept when we're talking about cloud forensics. The shared responsibility model is, well, who owns the forensics? Who owns it? And so we have to think about this. And there's 3 different little pieces here. Hardware normally is always going to be the provider's responsibility. You can't just walk into an AWS data center and seize the server. It's just not something that is doable. So that's probably going to be the owner of whatever cloud we're talking about. So in this graphic here shows Microsoft as the owner of the hardware. So Microsoft Azure for that example. The operating system and the data in IaaS. So it all depends on what type of model we're talking about. So if we're talking about OS and data, in the IaaS model itself, we're going to manage and secure the operating system, and it's normally the customer's responsibility. Therefore, you are responsible for imaging the virtual machine yourself. So who owns that data? Who owns that operating system? Well, it would be the customer. And so if we have a warrant for the customer's data, we can seize that data from the cloud provider because it's within their responsibility, it's within their ownership. Lastly, we have the data itself, otherwise known as SaaS, and the customer's responsibility is very limited in the SaaS model. If you look here, it's just information and data. It's basically the provider holds all the raw infrastructure, but the customer is responsible to properly configure and export their data logs. Just know the exam loves to talk about this one as well. A common scenario question will ask who was responsible for a breach of an operating system in an IaaS environment. The answer should be the customer, not the cloud provider. So make sure that you understand the shared responsibility model and who's responsible for what in the different types of cloud models there are. Now, investigating the cloud is fundamentally different than traditional on-premise forensics. We face some major physical and massive challenges, okay? The first one's going to be no physical access. That's where I was trying to jump to. You can't just pull the plug, stop the attack, and physically clone the hard drive using a write blocker. Just not something we have access to. Now, the other issue is going to be multi-tenancy. Your suspect's virtual machine shares a physical disk with innocent, unrelated companies. So a physical seizure is impossible without causing massive collateral damage. Lastly, is going to be volatility. Well, virtual machines aren't empirical. They're automatically spin up and handle web traffic, and they can be vanished seconds later. So when they vanish, they take all the RAM and local disk evidence with them. So that's really an issue when it comes to trying to gather evidence. So the empirical nature of cloud resources is something that needs to be highlight the need for like centralized logging. So hopefully the company we're doing an investigation for has centralized syslog servers, so that way if there's an auto-scaled EC2 instance and it's terminated, the logs will not be destroyed because we'll have them saved off to a syslog server. Now, the exam is going to emphasize that external log aggregation is the primary countermeasure to all of this volatility. So if they ask, it's going to be about log aggregation, so that way we can make sure that we keep all the logs as they're generated even if the machine no longer exists. Now, we're also going to fall into some major legal and judicial issues. Because remember data sovereignty. Data stored in the cloud actually resides in a physical data center somewhere in the world. And so we have to think about where that data lives. Now, there's a couple laws that we have to know about. The first law is going to be the U.S. Cloud Act. And this allows U.S. law enforcement to compel U.S.-based cloud providers to turn over data, regardless of what country the server is physically located in. And you have to be aware there it says compel. It doesn't actually mean they have to. There's other laws like GDPR, like European privacy law, that strictly regulates regulates and restricts the transfer of personal data outside of the EU and how it's handled. And then the last thing is going to be the MLATs. Now, this is something that's kind of become new in the industry. They're mutual legal assistance treaties. Okay, they basically are going to be diplomatic agreements that will say, if I need evidence from another country, do we have an agreement that's sitting there that says, yes, we can get evidence from another country, anything that's going to be across international borders. Now, jurisdiction is a major component of digital forensics. You need to understand that the data stored in a cloud data center in Germany is subject to German laws, even if the user uploaded it in the United States. This is where those MLATs are going to come involved with, mutual legal assistance treaties. They're kind of like a treaty that just allows us to get data from it. It's like data exfiltration that we can get, because otherwise we're only prone to data sovereignty laws of where the data physically exists. Now, if we can't seize physical disks, what evidence can we get? Well, there's a few things we can get. The first thing that we can look at would be the management plane logs. This could be like CloudTrail in AWS, and this is going to be API calls. It tells us who created a VM or who deleted the storage bucket. It's just kind of a log of everything that's happened within the consoles of a cloud provider. Other things we can get would be virtual disks. A lot of times this would be like EBS snapshots or VHDX files. These are going to be virtual copies of the hard disks that can be cloned and analyzed just like a physical drive. So if we get our hands on one of those, we can analyze that. We can do network logs like VPC flow logs. This is like NetFlow if you were talking about a tool that's on-prem. And it's just going to show IP traffic and port communication between cloud instances and different objects within the cloud. Last thing would be the storage log. So S3, for instance, in AWS, again, could be like the access logs. These are going to tell us exactly who downloaded or modified sensitive data and who authenticated to them as well. Now, we do need to differentiate between the management plane and the data plane. Management plane logs, like CloudTrail, was going to show infrastructure changes, like building a server. While the data plane logs are going to be like OS logs, S3 access logs, they're going to show the interactions with the data inside of those resources. So it depends on what we're looking for, is depending which logs we're going to be dealing with. And even did notice at the beginning of this chapter, I was saying, we're going to have a lot of logs to dig through. Well, this is one of those things that we will have our hands busy with. It's just log data. Now let's look specifically at AWS a little closer because they're currently the dominant IaaS provider for infrastructure. So your key artifacts here is to revolve around some of these native logging tools. The first one is going to be CloudTrail. This is the absolute black box of AWS. It's going to log things like every API call made to an account. The next one is going to be CloudWatch. This is the performance monitoring. Okay, this is going to be a massive tool to help us identify where were the attackers actually attacking. Performance monitoring is great to see like a spike in CPU utilization or any other types of indicators of compromise like cryptocurrency mining. The last tool would be GuardDuty, and that's an automated threat detection service. Think of it like an IDS for the cloud. And it's going to help flag behavior like EC2 automatically communicating with a known CNC network or something like that. Okay, like a botnet. Now we need to make sure that we don't confuse CloudTrail with CloudWatch. Trail is who did what API calls. Watch is for monitoring the system. So just because it has cloud in the front of it, just know the difference between trail and watch. Trail knowing who did what, while watch is monitoring how a system is performing, like CPU and memory utilization. Now, taking a deeper dive into CloudTrail itself, it's normally going to be formatted in JSON. A CloudTrail log is the ultimate trail audit trail because it is natively answers four questions: who, when, what, and from where. So we can easily see, like here's an example, that we can see the user identity here is hacker. We can see the timestamp of the event. We can see that it's a terminate instance event name. And we see the IP address is 192.168.1.50. Now be prepared that you may need to read basic JSON log snippets on the exam. You should be able to identify the attacker's IP address and the action they took just by looking at the key pairs. This is something that they love to question you on. Now, Amazon S3 buckets are frequent targets for massive data exfiltration breaches. Now, they're going to be used for server access logging, and they must be enabled manually. If it is, the log gets every get, every put, and every delete request from a bucket. This is really good because most of the time we're going to be dealing with data storage, and so this will tell us who did what and what happened here. But remember, they do need to be enabled. By default, it's not enabled, and so you'll have to turn it on. Now, object versioning, if enabled, this retains older versions of a file if it is modified. Now, this is a lifesaver from recovering data when it's destroyed by ransomware. It's kind of like a backup, okay? Do highly recommend using object versioning, but just be aware it does take up space because every version is going to have another version there, and cloud isn't just going to give you space for free. You're going to have to pay for that storage. Lastly is going to be the public access block. Now, this misconfiguration is the #1 problem that we see out there today. It's accidentally making a bucket public and allowing the public just to access the S3 storage. And the way that AWS does it is it actually an HTTP request. And so it gives you a web page with access to all the data. If that setting is set, we've got a leaky bucket. And so leaky bucket is a real world problem. It's massive. And so from an investigative standpoint, if a bucket didn't have service access logging or CloudTrail events enabled prior to the breach, it's going to be almost impossible to prove who downloaded exposed files and recover the files themselves. Now, if we shift to Azure, Microsoft, you're going to find that it integrates tightly with the Enterprise Active Directory ecosystem. Key artifacts are going to include things like the Azure Activity Log. This is where Microsoft is Microsoft's equivalent to CloudTrail. Okay, it's going to record all control plane events. This is just different things of like infrastructure changes themselves. Now, there's also going to be the intra ID logs, normally known as the Azure AD. And intra ID logs, this is where you're going to find a lot of authentication logs. This is sign-ins, user creations, password changes. They're going to be absolutely critical for identifying theft and account takeover cases. Lastly, we'll see the Network Watcher. And this is a powerful tool that allows investigators to capture raw network packets like PCAPs directly from virtual machines. Now, you do need to familiarize yourself with Microsoft Intra ID because Azure is so tightly coupled with the Windows Enterprise environment. Azure AD logs are the first place an investigator looks when an employee's credentials are compromised. Okay. The Azure's activity log, on the other hand, is where we're going to look for events that's going to help us filter the noise. Now, they're going to give us a couple different categorizations. The first one is going to be administrative. This is going to be events regarding resource creation or modifications. We're going to have service health. These are events related to Microsoft's own outages, which help rule out malicious activity during downtime. Service health logs just help us determine whether or not it was malicious or was there an issue with Microsoft. Remember, it's a shared responsibility model, so who's at fault? And then know that we also have security alerts here. And so these are normally going to be from the Azure Security Center. Okay. And to search these logs efficiently, we're going to use things like Azure Sentinel, and we need to be able to use KQL languages. So Elasticsearch and some of the other SIEMs out there also use KQL. It looks a lot like SQL, but it's not quite SQL. It's that Custo query language, and we'll have to know that. So we do need to understand the role of a SIEM, Security Information and Event Management System, in the cloud. Tools like Azure Sentinel aggregates all these logs from all these sources, so us as investigators can track an attacker moving from email compromise to an Azure infrastructure, or what systems did they touch. Okay, it is a great place for us to start when we're doing our cloud investigations. All right, let's move on to a SaaS product. So if we move to SaaS, something like Office 365, our investigations are going to focus entirely on identity and access, not disk imaging. So one of the things that I always like to look at here, for one, would be the Exchange Online. We're going to look at the email logs. Who read the CEO's email? Was there a malicious forwarding rule to steal invoices? Is there a SharePoint or a OnePoint drive? These are where all files are normally going to be accessed, so we can maybe get some file access logs. Or is there a Teams where we can have chat or meeting records where attackers are using this for like lateral movement? Because Teams is so integrated now with a SaaS product, they may have access to your OneDrive or your Exchange all through a single application, like a chat application. Now in SaaS forensics, you're going to analyze application layer user behavior. You can't use tools like Incase to image an Office 365 server, so you're going to have to use Microsoft compliance portals to extract and audit the logs. And they're going to give you access to these differently. And so you're going to have to be a subject matter expert in some of these portals, like with Azure, AWS, or even GCP. To investigate something like Office 365, here's what we're going to have to do. We're going to have to rely on the Unified Audit Log. This is a central hub that combines all the logs from Exchange, SharePoint, OneDrive, Teams, all into a searchable pipeline. By default, the standard license will only keep these logs for 90 days. So if we don't export them into a SIEM or have something our historical evidence will vanish. And as an investigator, our investigations can last forever. And so we may need to immediately try to see if we can get these logs exported out before they vanish. And so we will use something like a PowerShell commandlet, like search unified audit log, and that's our primary way of pulling the data for future extraction. So remember, if the breach happened 6 months ago, the client doesn't have like premium E5 licensing, then or external logging, just know that the URL evidence is already gone permanently, that data is only there for 90 days. Now, the URL is primarily used to investigate things like BEC, business email compromise. There we go. And the most common financial motivation will be a SAS crime. So we may look for specific forensic indicators in the log itself. For one, we may look for things like impossible travel. Did the person travel from New York to Nigeria within an hour? Well, that's impossible travel, so that's definitely going to be an indicator of compromise. What about inbox rules? Like if subject contains invoice, move to RSS feed folder to hide fraudulent replies, right? Or forward it to another email, which is also forwarding, auto-forwarding anything to like an external address. Now, an inside user could probably try to forward something to an external address because they just hate your email system. So just know that this could be an insider threat, malicious or not. We may need to check into it. So BEC is heavily focused on the exam. We need to identify things like malicious inbox rules and understanding the concept of like impossible travel. Because if you know what impossible travel is, then easily you could look at a geographical log and be like, ooh, there's impossible travel there. How did they get from New York or Denver to the UK? Now, they're really good about giving this pretty generically like on their logs on the test, so don't worry about knowing, well, I don't know all the geographical cities. They're pretty generic where they say, hey, this was from the United States and now they're in Russia or something in that nature. They'll go quite large with it. Now, when we transition from log review to actually acquiring data, we can use a couple different remote strategies. The first one that we wanted to look at would be like API extraction. We are going to use provider APIs like Microsoft Graph or AWS CLI, okay? And we're going to pull these logs automatically or programmatically through data containers. Other ways that we can get it would be snapshots. This is the cloud equivalent of disk imaging, which is great because we can create a point-in-time copy of a virtual hard disk, and it is forensically identical to the original. Lastly would be live agents, and we can deploy specialized live agents like fresponse to run directly on the VM to capture things like anything volatile, like RAM or anything over the network. Especially if we want to keep an eye on a live malicious server that we have access to see if we can trace back its command and control. Now, for the exam, make sure that you understand that API extraction is fundamentally changing forensics, okay? Instead of connecting a hard drive to a USB, we're going to have to use things like Python scripts and REST APIs to download forensics evidence directly from a cloud provider infrastructure. Now, let's talk about snapshots a little bit. So snapshots are the gold standard for cloud acquisition because they are non-disruptive to a production server, and they're pretty easy to get because they're forensically sound. So in order to do that, first we're going to identify the target volume. Maybe it's an AWS EBS storage volume. We're going to snapshot the volume, which takes seconds really in the cloud environment, which creates a brand new volume from that snapshot. We can then mount that volume to our forensics workstation in read-only state right in the cloud. And then we can image or analyze the mounted volume without ever touching the original suspect's machine. Now, this is a very modern equivalent of traditional dead box forensics, because if we snapshot it and isolate the copy in a forensics VPC, we're going to preserve the original evidence while safely analyzing the clone. This is something that is a little bit different that we have to start getting used to as technology changes. Now, sometimes a static snapshot isn't enough. You may need the contents of the RAM to view active network connections. So I mentioned F-Response. Now, F-Response is a commercial tool that gives us a secure iSCSI tunnel over the internet. Now, we can mount the remote RAM or disk to our local forensic laptop, just like if we were plugged into it locally. Now, it's really cool. They can do that, but remember, we're over the internet, so let's see how long this is going to take. It could take some time. We can also use SSM run commands, which are native tools like AWS System Manager. Now, some of the tools like AWS and Azure will give us those commands so we can run a remote command like netstat or DD on instances securely without even needing SSH access or port firewalls. It's kind of like using the back door. So live memory acquisition is critical because, as we all know, fileless malware is going to be, well, it's increasing in popularity, and it runs 100% in RAM. And so it'll never write to the actual EBS volume itself. You can only take a snapshot and reboot the machine. And if we do that, well, the malware would be lost forever, and we wouldn't be able to do our investigation. So we want to sometimes get that live volatile information if we can. Now, cloud forensics isn't just the cloud. It leaves traces on the local computer as well. When users sync to cloud storage on their desktops, some artifacts could be left behind. For example, Dropbox is going to leave an info.json file. And normally we'll even see their database file called filecache.db. This is going to tell us all the files that it cached throughout its system. Could Google Drive create something called sync-log? And they also have a snapshot.db. OneDrive has a .dat file in the apps folder, and so by analyzing the local hard drive, we can prove what a user synced to the cloud account. And this is going to help us bridge local and cloud forensics. Knowing that Dropbox uses SQLite databases locally allows an investigator to see historical list of files that are stored in the cloud, even if the computer is currently offline and the cloud account currently is inaccessible. So we can prove that that file was at least one point on the computer. Finally, we need to consider things like shadow IT. This is the hidden cloud. This occurs when employees use unauthorized cloud apps like Gmail or WeTransfer to bypass things like corporate security policies. This is normally going to lead to data leaks. Now, we need to detect shadow IT forensics by checking for local artifacts. We can check their local firewall logs, the browser history, or the prefetch files for all of these different things. Now, shadow IT is a massive compliance and security risk, okay? From an investigative standpoint, discovering an unauthorized Dropbox client installed on a local machine immediately expands the scope of data theft investigations to include external cloud providers. So unfortunately, this is starting to get more complicated as we go through. Now, to accomplish all of this, we may need to have a couple things in our toolbox, right? We need to know the cloud providers themselves and know their native tools, AWS, Azure, GCP. We need to know them. We need to know some of the commercial suites like Magnet, Axiom, or Celebrite Cloud, because this will help us connect directly to the APIs of all these cloud providers and download like entire mailboxes or backups. Or we may even need to use some of our open source tool, like from the SANS tool for like log ingestion, which is SOS ELK, which is Elastic. It stands for Elastic Logstash and Kibana, and it's basically a SIM. Okay. And this is also going to be a good time to bring up things like Scout Suite, which is also another free tool that's great for log auditing. Okay, so just be aware of what the names are and the industry standard tools, because the exam may just ask you the appropriate tool for acquiring cloud-based Office 365 accounts or auditing an AWS infrastructure. So you just need to know the tools and what they're used for. May not have to. You don't need to understand how to use a tool specifically. So to summarize chapter 12, we talked about shared responsibility, knowing that logs are king, especially when it comes to cloud. We talked about acquisition and how snapshots are a primary static disk acquisition method. We talked about SAS environments and how logs, again, are just such a big overarching theme for this exam. And that cloud forensics themselves are going to require a shift from hardware-centric thinking to log-centric and API-centric thinking. Remember, always secure the logs first, because remember, we have some of these logs that are only going to last for 90 days. All right, so that is chapter 12. Quite a long chapter for that, but cloud is such a deep topic. And so if you have any questions, let me know. Otherwise, I'll see you for chapter 13, which is emerging threats. Make sure that you know the differences between your models and your deployment models, and know that many exam questions are going to be hinged entirely on your understanding of technical limitations on cloud services for what model in what specific scenario. All right, see you for chapter 13. Good luck.